So 29, page 29 is a continue of rationalizing, right? Let's quickly recap what happened last time. When we try to rationalize denominator means we want to make the denominator become a rational number, right? If you see a radical, you want to make it go away. So there are two types of the question. One type is when the denominator has one term, okay, like the question you see on page 27. So all you need to do is just multiply by the same radical, right? On page 28, you get two terms in the denominator, but then the numerator has one term. So you multiply by the conjugate. Conjugate means you have two brackets, one has minus, one has plus in the middle. Okay, so you use the difference of square and then you can get rid of the square roots. So the one on the next page, which is what we're going to do right now, is the same thing. The only difference is, what do you see? What's the difference now? Yosher?
There's two terms on the top.
That's right, okay? So for the two terms on the top, you don't need to worry about conjugate to the top, okay? You still focus on conjugate for the denominator, right? That's your goal. So for the top, you just do the FOIL as usual, okay? So show one, okay? So let's go over question A. Eric, so if I want to rationalize denominator here, what do we need to multiply with?
I forgot the term again, but like you changed the sign, so it's 3 root 7 plus 2 root 5.
Yep, that's right. Numerator and denominator.
Is it conjugate?
Yep, conjugate, that's the word. Okay. So I'm going to put brackets, okay, because there are two terms. So it's better to have brackets, so you know you need to do distributive, okay? We'll start with the denominator first. Denominator has a minus, oops, that's a minus, and then a plus, so they are conjugate. So we use the formula. Right, so Colin, can you tell us what happened to the denominator?
So you do like 3 root 7 times 3 root 7.
Okay, so I'll write square and then?
3 root 7 times 2 root 5. Or is it just like minus 2, 3 root 7 and then 2 root 5?
Minus 2. Oh, no, this one is a difference of square.
Oh, so it's minus 2 root 5 squared.
Yeah, okay, because the denominator is like a minus b, right, times a plus b. So it should become a squared minus b squared. Okay, so minus 2 root 5 squared. The a is the 3 root 7, b is the 2 root 5. All right, and the numerator we have to do one by one. Okay, so you need to distributive 1, 2, right, and then 3, 4. Okay, you get a total of 4 terms. So Brendan, can you do the numerator?
So it's 6 times 7.
6 times 7, yeah, very good.
Plus, yeah, 6 times 7 plus 4 root 35.
Yeah, 4 root 35.
3 root 45. Sorry, 35, yeah.
Yeah.
And plus 2 times 5.
Yeah, 2 times 5, very good, okay. So some of the multiplication got rid of the root, okay? Now let's simplify, okay? We'll start with the denominator again. So Aaron, what's the denominator become now?
63 subtract 20.
Yep, very good. Okay, so 63 comes from 9. 3 times 3 is 9. 9 times 7. And the 20 is 4 times 5. Okay, now for the numerator, we want to simplify, right? So Eric, how do we simplify the numerator?
It's 42 plus 7 root 35 plus 10.
Anything else we can do for the numerator?
You can change to 52 plus 7 root 35.
Yeah. Okay. Thank you. Very good. And denominator, we just subtract. That gives us 43. Okay. And before we say it's the final answer, we need to check again, right? Sometimes in the radical, there could be something to take out, right? So for the 35, we think in our head, right? 35 we can break down into 7 times 5, and that's all, right? There's no pairs to come out, so that's it. And you check the denominator, no more radical. Okay, then we're done. Then you can call it the final answer. Okay, so you made, by using the conjugate, you make the denominator becomes rational numbers, right? Used to be 3 root 7, 2 root 5 there. It's gone, right? No more radical. So now it's your turn, okay? So I'm gonna let you do the 3 questions on the right side and bottom, okay? Follow the same steps. And then when you finish the 3 questions, we'll go over them, okay? You can raise your hand when you're done. Okay, we have one person finished. So maybe 3 more minutes, okay? Should be done by then. Okay, we have 3 people done. Okay, let's get some answers. Okay, Eric, what question are you on?
B.
The bottom part, right?
Yeah.
Okay, can you tell us your answer for the B on the top? What's your final answer for that?
Okay, let me just double check.
Okay. What is it?
I have root 12 plus root 50 over -4.
Okay. All right, and Brendan, can you tell us question A at the bottom, your answer?
Got 3 minus 2 root 2.
Over anything?
No.
Okay, over nothing. All right, and question B at the bottom column, what's your answer?
6 plus root 21 over 5.
Rule 21 over 5. Okay. All right, so does anyone want to add in your answers? Do you have a different ones? Yosher, do you have anything that's different?
I have a different one for the top B, but I
Yeah.
think I did it wrong.
What's your answer?
It's 2 root 3 plus 2 root 5 plus root 30 plus 5 root 2.
Oh, I can't fit it in my rule too. And then over anything?
-4.
Over negative
Yeah,
4.
I got that as well.
Yeah, I got that as well.
Okay,
It
I'll
just seemed
come.
weird, so I didn't bother to mention it.
Oh, okay. Looks weird. Okay, we'll see. Okay, let's see what happens.
It's over root. It's over negative.
Over rule 4, over negative 4, yeah. Okay. Anything else that's different? Okay, so looks like B is the only one, right? Okay, so we'll quickly go over that one. So for B, the conjugate is the opposite, right? So root 6 plus root 10, root 6 plus root 10. And then for
I think I
denominator,
forgot about the multiplication rule.
huh? Which one?
I think I forgot about the multiplication rule for the top part.
What do you mean multiplication rule?
It's like the a squared plus 2ab plus b squared.
Yeah, did you use that?
No, I forgot to.
But is there a place to use it?
Not really, but like it's like the first outside inside last thing.
Oh, okay. The FOIL, you mean FOIL, right? Right, so for denominator, right, you square the a, which is the root 6, that'll give you 6, minus square the root 10, will be 10. Okay, and for the numerator, you just expand. So that give you root 12, right? And then plus root 20, and then root 30, and then root 50. Right, so of course you don't stop there. You need to simplify as much as you can, right? So you look at the top, right? The 12, we can take something out, right? We can take the 2 out. For 20, we can also take the 2 out. And then 30, nothing can be taken out. And then 50, you can take the pair of 5 out. Yeah, okay. And then you look at the inside, right? We have root 3, root 5, 30, and the 2, nothing the same, right? So there's no like terms, right? Or like radicals, so we cannot combine anything. So even though it look weird, you still have to call it the answer, right? Okay. So let's erase that. So not everything works perfectly, like question 8, right? Sometimes it will add it up, right? You're able to add together. Sometimes just trying to trick you into thinking you got something wrong, right? Okay, next one is root 2 minus 1. So denominator, square the first, minus square the last. And then the top you could use the special product, right? The top is like a minus b squared. Okay, so you could use that formula, then you don't have to use the FOIL. So what's the formula for a minus b squared? This is the special product we learned, I think, last class, right? Aaron, what's the formula for that?
A square subtract 2ab plus b squared.
Yes. Okay, very good. So instead of doing the FOIL, we just put it into the formula, right? A squared, so that will give us a 2 minus 2ab, right? And then plus b squared, which is 1. And then you just simplify 2 plus 1, that gives us a 3. 3 minus 2 root 2 over 1. So that's why you don't need any denominator, right? So you adapt to different situations. Sometimes you have to do the FOIL, sometimes you apply the formula, okay? And then last one, right, Eric, what's the conjugate you multiply with?
4 root 7 plus 3 root 3.
Yep, very good. 4 root 7 plus 3 root 3. All right, so let's start with the denominator. Colin, what's the denominator become?
4 root 7 squared minus 3 root 3 squared.
Okay, square minus 3 root 3 squared. Okay, and then the numerator, Brennan?
It's 12 times 7 plus 9 root 21 plus 8 root 21 plus 6 times 3.
Plus 6 times 3, okay. Right, so for denominator, we have to square each one, right? So 4 times 4, 16, 16 times 7. What is that? Yosher?
That is 112 minus 27.
Minus 27, okay. Yeah, so 9, 3 times 3, 9, 9 times 3, 27, okay. And then we go to the top. The top we have 12 times 7, that's 84, right? 84 plus, those two can add it up in the middle. So 17 root 21, right? And then plus 18. Okay, and then we can start subtracting, right? And adding together. Colin, what's on the top now?
102 plus 17 root 21.
102, okay. 102 plus 17 root 21. Okay, and then denominator, Eric?
It's 85.
85, okay. So how do we get to the answer of that?
divide by 17.
Oh, so all the number can divide by 17. Yeah, okay, so 102 divided by 17 is 6, right? So when you divide, right, so this part you have to be careful. If any of the numbers here is not divisible by the same one, then you cannot reduce, right? So this one is just happen to all divisible by 17, so you can reduce them all at once, okay? So divide by 17 give you 5 here, and then this one give you 1, and then give you a 6, okay? So reduce into 6 plus root 21 over 5. So it's pretty good. You guys saw that it can be reduced, right? A lot of people, they just stop in before reducing, because 17 is a big number to try, right? So you guys did good. All right, so that's all for operations, right? Everything here is about operation. We did add and subtract, right? Add and subtract radicals. Multiplying, you have special product. Dividing, you have rationalizing, okay? So learning how to do operation is for us to work with some word problem, okay? That has a square root inside, okay? So let's just look at 2 questions that has radicals in them. So page 30. Let's start with question 11, okay? So here it mentioned there's a city A that is 8 kilometers due west, meaning on the west side of city B on the map. Okay, so in your head, you should try to locate where they are now. Okay, west. West is on the left side. However, if one wants to travel from A to B by car, one must go through city C. And where is city C? City C is 1 kilometer east and 1 kilometer north of city A. So how much farther is it by car than by airplane from A to B? Okay, so I would like you guys try to make a map on your paper now, okay? And I'll pick one of you to draw on the screen, okay? And see what you think it should look like. Where city A, B, C are, okay? And where's the numbers? The 8 kilometer, 1 kilometer, where do you put them? Okay, when you finish drawing, please raise your hand. I'll put a picture on the left side here, okay? Diagram. On the west side, due west means on the west side. West side means left side. North means the top, okay, above it. East, think of it as on the right side. So by car, you have to travel on the road, right? So and then if it's airplane, you can go in straight line. That's the difference. So one by car, you want to compare the car and airplane, okay? the distance for each one. We only have one drawing so far. What about the rest of you? Right, this is what happens when you have a word problem, right? You have to turn the words into something easier to understand, right? So change the words into pictures, right? That's one way, turn it into diagram, or you turn the words into equations, right? Then you solve for it. Okay, Brendan and Eric, do you have any pictures on your sheet? Okay, do we have any volunteer before I pick names?
I have city A on a point and then city B on a point.
Okay, do you want to draw on the screen?
Give me a second.
Because this one, it tells you exactly where they are, right? So everyone should have the same drawing. Anything else? I see the 2 dot and the A. And B. Okay, and then and C. So you have 1 and 1. And where's the 8? That's 8, okay. Okay, thank you, Eric. Very good. Anyone else? Anyone else got a different interpretation? Does everyone got the same picture?
Mine is flipped.
Yours is flipped. So
Like A is on the left side and B is on the right side, and then C is like in between
you
A
should
and B.
on the
But
screen. Where do you put the C?
do I have to like draw?
Yeah, yeah. Do you know how to use the drawing function?
Like C is here,
Okay.
and then
So C.
yeah, and then like this, it's one kilometers like north and east.
Okay. So 1 here,
Yeah.
and 8. Okay. All right. Thank you. Anyone else? Colin, what do you think? What picture do you have?
I have the one on the bottom.
Okay, okay. So the direction is important, right? So let's break down, right? Break down one sentence at a time. A is on the west side of, right? Due west means on the west side of B. Because if you get pictures different, right, you get a different setup for the calculation, right? So A is on the left side of B, right? From the first sentence, we know A should be on the left side. Okay, so A and B should be flipped around instead of B to A. And then if one wants to travel from A to B by car, one must go through C. Now it tells you where is C. C is on the east side of A, right? Also on the north side of A, right? So you have to go east, which is the right side by 1, and then go north by 1. So that gives you C. Okay, 1 km. 1 km. All right, so you have A to B. This part is 8 kilometers. Okay, so if you want to go by car, it tells you must go through C. So for the car's path, I will use the red. Okay, the car, you go this way. All right, we assume all the paths are straight lines, right? So red is the car. Okay, I'll draw a little car. All right, by car. Looks like UFO to me. Okay, and if you want to go by airplane, you go on the blue path, right? So that's your picture, right? And with all the numbers in there. So you want to compare how much further is it by car than by airplane, right? As you can see from the picture, car takes more longer distance, right? So you need to compare both, find out both distance, and then find out how much longer, okay? So I'll let you guys try that. Think about what to do, come up with a plan. No decimal here. Okay, my screen just shut off. I'll restart, but you guys can start working on it. Okay, so everything has to be in terms of radicals, no decimal at all. Okay, so find the distance traveled by car, and then you can raise your hand. Okay, once you found the distance by car, please raise your hand. We already know the distance by airplane, right? So we don't need to find the distance for airplane, just find the car distance. Okay, so for car distance, okay, Brennan, what did you get for the car distance?
6 root 2.
6 root 2. Can you tell us how you get it?
So 7 squared plus 1 is 50, and
7
you
squared.
just take the square root of that.
Where did you get 7 and the 1?
Well, no, 7 and 1 is like it's like for the triangle,
Which triangle?
the second one.
The one on the which side?
right.
On the right side, okay. So you are using the something called the what? There's a theorem.
Yeah, Pythagorean theorem.
Yeah, Pythagoras theorem. Very good. Okay, so we break it down into two triangles. You get a 7 kilometer on the right side and 1 on the top here. So 7 square plus 1 square give you the 1 of distance. So
And you
40.
get root 50.
Yeah, root 50. Okay, so D will be root 50. Okay, and then?
And then the triangle on the left, which is just root 2 for the answer.
Root 2 for the answer. Okay, so
Yeah.
we do 1 square plus 1 square give you the other distance. D is root 2. And then?
And then you simplify 50 to 5 root 2, and then you add them together.
Okay, very good. So this question needs you to combine simplifying, right? Also add and subtract, right? So we are not using calculator at all, right? So 5 root 2 plus root 2 give you the total distance of 6 root 2. Okay, and Aaron, how are you doing? Did you get the answer for car distance?
I'm not well, yeah, I got 6 root 2, but
Right, 6 root 2 is the distance by a car. But now the question is asking how much farther. So what do we do now, Colin?
So it's 8 minus 6 root 2.
8 minus 6 root 2. Which one is longer?
8. Oh, I mean 6 root 2.
Yeah, right. 6 root 2 is the car distance, right? So it should be longer than the plane. So how much further you should take the longer one? Minus 8. Okay, and can we subtract them together somehow? Aaron?
make it to 2 root 2.
Which one make it into 2 root 2?
The 8.
Is 8 inside the square root? Is it?
Nope.
No, right? So it cannot simplify. 8 is 8. 8 is outside, right?
Oh,
Yeah, okay. You are so used to simplifying. We look at a number, we want to take it out. But it's not even inside, right? So that's it, okay? So this one is how much further, okay? The car by the airplane, okay? Because it's not a decimal. If you want, you can type it all into calculator, right? 6 root 2. Can somebody type it into a calculator? Okay, Eric, do you have an answer in decimal?
I'm just doing it right now.
Okay.
I have 0.49.
0.49. 0.49. Can someone confirm? Sarah?
Yep.
Yeah, 0.49. Okay, so this one has units, right? It's a word problem. We got to answer in a simple sentence. You can just say car travels 0.49. Oh, we shouldn't use 0.49, right? 6 root 2 minus 8 kilometer further. Okay, so for word problem, you have to turn the words into pictures and then using pictures and then try to find the answer. Okay, we have another one. This one should be easier. They give you the picture already, but then the question is needs more thinking, right? So let's look at the picture here. We have kind of similar picture, right, as the car and airplane. But instead of simple number, we have 4 root 2. 4 root 2 is from A to D. Okay, and 5 root 3 is like the height. And 2 root 50 is from A to C. So question A asks you to show that angle ABC is not 90 degrees. Right, angle ABC is talking about the angle at the top. We want to somehow prove that, have a reason to say that it's not 90 degrees. It looks like it's 90, right? But how can we show it's not 90 degrees? Okay, I would like you guys think about this one first for a minute. When you see a 90 degree, right, it's in a triangle, it's a right triangle. So think about right triangle. What have you learned before? Anything about right triangles? Okay, give you a minute. Okay, minutes up. Okay, Aaron, what have you learned about right triangles? Aaron, are you there?
Yeah.
Okay, can you tell us what you remember about right triangles?
That they're supposed to be 90 degrees.
Yes, yeah. Any other things you learned in the past 5 years of math? What else? I don't believe you only know it's 90 degrees, right? Anything else that's connected to right triangles?
The other side is 45.
The other side, you mean the angle?
Yeah, for right angle triangle.
For right angle triangle, so like this, and then you said this is 90 degree, and then where's the 45?
On the two other angles.
Okay, so if this is 45, the other one will be 45. Does it always have to be 45, 45?
Yeah, to
Always?
make it 180.
So has to be 45? Cannot be other angles? Can I make it smaller?
I'm pretty sure, yeah.
It's okay, right? So 45 is not really a rule, right?
Oh yeah, right. It just has to add up to 180.
Yeah, okay. So if, for example, if one angle, let's say is 20, what's the other one?
70.
70, right? That's okay. Still keeping a right triangle, right? So it doesn't have to be 45. Okay, keep thinking what else? What else other than add up to, okay, so one thing, right? We can write that down. That's a good point, right? 3 angles add up to 180. 3 angles adds up to 180 degree. And right angle is 90 degree. Okay, what other things have you guys learned about right triangles? Because right now, number one, right, the adding up to 180 doesn't help us in this question. We don't have any angle, right? All we know is 90 degree, but we don't know any of them, any of the other ones. Brandon, how about you? What have you learned about right triangle before?
I don't really know the answer to what we're trying to do here.
It's okay. Just we're trying to recall, right? What things, what knowledge you had before you had learned about right triangles.
I mean, I have a lot of answers, but probably none of them are going to be right that can relate
Okay,
to this.
share
question.
one if you have many, right? Share one. Yeah, what can you?
Well, I remember trigonomic ratios and how like
Okay, trig ratio, good. Trig ratio, can you tell me more about that? Trig ratio, what's that?
like how cosine of 90 degrees is 0 degrees.
Okay, so sine, cosine, right? And tangent, those things, right?
Mm-hmm.
Okay, that's a good start. So once again, right, same thing here. We don't have any angle inside, but you're right. Sine, cosine, tangent, they all have to do with right triangles. Okay, but unfortunately, we don't have angles in here. So that's also out, right? Okay, what else? Keep thinking. Colin, what do you think? What else have we learned about right triangles?
I just use tangent to find out angle A and angle C.
Oh, okay. So you use tangent to find out angle. So you are using trigonometry to find the angle.
Yeah.
Okay. So let's say you find find the angle and then find the angle C. So you have to use a calculator then, right?
Yeah.
Tangent inverse. Okay, then maybe we need to add in a new rule. No calculator. Yeah. Okay, no calculator, then you cannot find angles. But that's a good point, right? If you can use calculator, then you can start using the trig ratios, right? To do inverse, find the angle. Okay, so still got to do with trig ratio, but since we can use calculator, can do it. What else? What else have we learned about right triangle? We're still missing another info here. Eric?
The Pythagorean theorem.
Pythagoras theorem. Okay,
Yeah.
Pythagoras theorem. Yeah, that's got to do with right triangle, right? We have the a squared plus b squared should equal to c squared. And in fact, we just used it at the top, right? So can we use it to, can we apply this here? Yosher, can we use a Pythagoras theorem here?
If you solve, if you use it and a squared plus b squared doesn't equal to c squared, does that work?
Okay, very good, right? For Pythagoras theorem to work, it has to be 90 degree, right? So in other words, if the a squared plus b squared doesn't work, a squared plus b squared equals c squared doesn't work, if the Pythagoras theorem fails, that right away tells you that the triangle is not a 90-degree triangle. Okay, so since we are working with length, right, there's no angle at all in the picture, and you cannot use the calculator. So you have to use the length. The only one that you learned before that has length is Pythagoras theorem. Okay, so to show that it's not 90 degree, right? So we look at the logic here is if a squared plus b squared equals c squared, then it's a right triangle. Right? So in other words, if it's not, okay, I should write the opposite, okay? Sorry. You should be given the right triangle first. If it's a right triangle, right? Then a squared plus b squared should equal to c squared. So if you say a squared plus b squared does not equal to c squared, then it's not a right triangle. Okay, so we need to somehow show the a squared plus b squared doesn't equal to c squared. So where's our ABC? Okay, if you look at the picture, okay, you guys can copy this down first. Okay, can you raise your hand when you finish writing this part? Okay, so we'll draw a picture now. Okay, so from the picture, we want to show this one, right? Show this one if it's a 90 degree. Here's A, here's B, here's C. So we need to check if AB, square AB is here, plus BC squared equal to AC squared. But it tells us to show it's not, right? So we need to show that they don't equal. Okay, so there you go. So you need to find AB first, and then find out what BC is, right? See if they add up, and then doesn't equal to AC squared. Okay, so I'll let you guys start now. And find the length of AB. And also find the length of BC. AC is already given in the picture, right? It's 2 root 50, right? So once you found the AB and BC, you can raise your hand. AB is here. That's the red. BC is the green part. It's here. To find AB, you look at the left triangle, right? Because there's a right triangle, smaller one. To find the BC, you look at the right side, right triangle, right? Okay, has anyone found AB by now? Okay, Brennan, what's your answer for AB?
I got root 107.
Root 107. Okay. And Colin, what's your answer for BC?
Root 147.
147. Okay. Aaron, do you have anything different? A, B, and B, C?
I got the same for both of them.
Okay. And Yosher, how about you?
I also have the same.
Same? Okay. All right, so let's go over. All right, so to find AB is the hypotenuse side, right? The longest side. So the setup, right, to find AB, I'm using red, okay? AB squared. So it will be 4 root 2 squared plus 5 root 3 squared equal to AB squared. 4 root 2 squared will be 32, right? 16 times 2. And then 5 root 3 squared will be 25 times 3, so 75. Right, so that's 107. Yep, you're right. Okay, so that one's good. And then we look at the green one, BC. Okay, to figure out BC, we need to know how long CD is. Okay, so to find CD, Eric, have you found out how long CD is?
Not yet.
Okay, can you help us find that first? How do you find the length of C to D?
So is it 5 root 3 squared plus 6 root 2
Where's the
squared?
6 root 2 from? Where does 6 root 2 come from?
D to C,
How did you get 6 root 2?
because it's 2 root 50 for the whole thing.
Yeah, and then
So you simplify, which is 10 root 2,
10 root 2, okay?
and then you subtract 4 root 2, so it's 6 root 2.
Okay, okay, very good. Okay, so 6 root 2 for DC. Then we can apply the Pythagoras again, right? So we have 5 root 3 squared plus 6 root 2 squared equal BC squared. 5 root 3 squared, we did that already, 75. This one will be 72, right? 36 times 2.
Yeah.
Okay. And then 147 is BC squared. Okay, so we need to check now, right? We found our AB. We found the BC, right? Do they square add together equal to BC squared, AC squared? So let's check that, right? So AC squared plus BC squared, does it equal to AC? AC is 2 root 50. So we have root 107 and root 147. Okay, so for the left side, let's move it up, okay. For the left side, we have 107 plus 147, right? Because square and square root, they canceled out. So that gives us 254, right? 254. Okay, what is the square of 2 root 50? Sarah?
200.
It will be 200, yeah? Okay. So this is what you need to show, right? The left side, AB squared plus BC squared, it does not equal, right? Does not equal to the other side square, right? Doesn't equal. So therefore, it cannot be a right angle at angle ABC, okay? So because AB squared plus BC squared is not AC squared, therefore angle ABC is not 90 degrees. Okay, so the calculation is not too bad, right? Not too difficult. It's the how to show it is hard, right? The thinking behind it. So let's have a break, okay? And then we'll continue the rest of the topic at 11:35, all right? I'll see you guys soon.